In this example, I need to use the quadratic formula to solve the equation 2x squared equals 4x minus 5. Often with solving quadratic equations, it's up to us to decide how to solve them, but in this case, we're told we must use the quadratic formula. Now, whether we're using the quadratic formula or factoring, we need to have the equation in standard form. What standard form? That's when we have all terms written in descending order on one side, 0 on the other. Is that what I have in this case? No, I have terms on both sides of the equation. So I'm going to collect all my terms where my squared term is positive. So that's going to require me to subtract 4x and add 5 to both sides of the equation. And on the right-hand side of the equation, I get 4x minus 4x is 0. Negative 5 plus 5 is 0. So on the right-hand side, I just get 0. On the left-hand side, I have 3 unlike terms, can't combine them. I need to write them in descending order. Start with the x squared term, so I have 2x squared. Then the x term minus 4x plus 5, the constant, equals 0. So now my equation is written in standard form. I can now find the values of a, b, and c. A is the coefficient of the x squared term, it's 2. B is the coefficient of the x term, it's negative 4. And c is the constant term of 5. Here is the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So now all I have to do is plug the numbers in. Negative b. b is negative 4, so I have the opposite of negative 4 plus or minus the square root of b squared, so that's negative 4 all squared, minus 4 times a times c, so that's 4 times a is 2, and c is 5. That's underneath the square root, and the whole expression is divided by 2 times a, which is 2. Now all I have to do is simplify. The opposite of negative 4 is positive 4, plus or minus the square root of negative 4 all squared. Well, negative 4 times negative 4 is positive 16, minus 4 times 2 is 8, 8 times 5 is 40, divided by 4. So I get x equals 4 plus or minus the square root of 16 minus 40 is negative 24, all divided by 4. Now be careful, it might be tempting to reduce these two 4s. We can't do that because this 4 is not a common factor in the numerator. So I'm going to have to simplify the square root of negative 24. The first thing we do is we pull out the square root of negative 1 as I, so I get I times the square root of 24 over 4. And now I need to factor 24, and there's many different ways of doing this, but 24 is 4 times 6. 4 is a perfect square, leave it alone. 6 is 2 times 3. No perfect squares hidden in that. So x equals 4 plus or minus I. Instead of the square root of 24, I'm going to have the square root of 4 times 2 times 3 is 6, all divided by 4. So x equals 4 plus or minus, now the square root of 4 is 2, so I'm going to write 2i times the square root of 6. And to simplify this, it's a lot easier if I break up my expression into two terms and divide 4 into each of those terms. And this gives me x equals, in the first term, the 4's reduced. I get 1 over 1, which is 1. Plus or minus, in the second term, I can reduce a 2. 2 goes into 2 one time, 2 goes into 4 twice. So I have 1 times I times the square root of 6, which is I times the square root of 6 divided by 2. So there are my solutions to this quadratic equation. Because of the plus or minus, there are two solutions. And if you had to write them individually, it'd be x equals 1 plus I times the square root of 6 over 2, and x equals 1 minus I times the square root of 6 over 2.